The Dreamer's Vision, Tesla's wireless world welcome. Close your eyes for a moment, breathe deeply. Right now, imagine a world where energy flows invisibly through the air itself, where every home receives power without wires, without cables, without the infrastructure that binds modern civilization to the ground beneath our feet. Picture this possibility: a single tower standing against the sky, transmitting boundless electricity to every corner of the planet. This is not science fiction. This was the vision of one man, a mind so far ahead of his time that the world could not comprehend what he was offering. Nikola Tesla possessed a consciousness that operated on frequencies most people could not perceive. He walked through the world seeing patterns, waves, and invisible forces that others overlooked. His imagination did not merely dream of inventions, it calculated them with precision, visualized them in perfect detail, and understood their mechanics before they were ever built. Tesla believed that the Earth itself was a conductor of magnificent power, that resonance and frequency could move energy across vast distances without any physical connection. This was not wishful thinking. This was a scientific framework, a hypothesis built upon electromagnetic principles that he had spent decades studying. The promise was revolutionary: free energy for everyone. Not free in the sense of unlimited supply, but free in the sense of liberation from monopoly. Energy would belong to those who needed it, transmitted through the atmosphere and the ground, available as naturally as rain or sunlight. No corporations controlling distribution, no metered systems determining who could afford power and who could not. No cables snaking through cities, no power lines dominating the landscape. Just pure wireless transmission of electricity from transmitter to receiver. Before we begin this journey through history, science, and the collision between visionary thinking and economic reality, I invite you to subscribe to Relaxing Science. Give this video a like and share in the comments where you are listening from and what time it is in your location. Your presence here matters, and your engagement helps us continue exploring these mysteries that reshape how we understand our world. Tesla's vision emerged from a mind that operated differently from his contemporaries. While others saw electricity as something to be controlled and sold, Tesla perceived it as a fundamental force of nature, something as abundant as the air we breathe. His wireless transmission concept was not born from desperation or fantasy. It emerged from genuine scientific experimentation, from mathematical calculations, from careful observation of how energy behaves when certain conditions are met. He had already revolutionized the world with alternating current, with the induction motor, with wireless communication technologies that prefigured radio. This new idea followed logically from everything he had already achieved. The year was approaching 1900, and the world was electrifying. Cities were beginning to glow with artificial light. Factories hummed with electric motors. The age of electricity was arriving, and those who controlled its distribution would control the wealth of nations. But Tesla saw something different. He envisioned a future where energy was as free as thought itself, where the invisible forces that moved through space could be harnessed and directed with the same precision that a musician directs sound through an instrument. This vision would consume the next chapter of his life. It would drive him to build something extraordinary. It would lead him to seek funding from the most powerful man in finance. It would result in the construction of a tower that still stands today as a monument to ambition, to the possibility of what might have been, and to the forces that can suppress even the most brilliant ideas when they threaten established systems of power and profit. Tesla's wireless world was not a fantasy. It was a specific, engineered solution to a real problem. The problem was this: as civilization expanded, as electricity became essential to human life, the infrastructure required to distribute it became increasingly complex and expensive. Wires had to be laid across continents, towers had to be erected. Maintenance required constant attention. The system was centralized, controllable, and profitable, but it was also inefficient, vulnerable, and dependent upon the willingness of those in power to share its benefits. Tesla proposed something radical: a system that could not be controlled by any single entity because it operated through natural forces that belonged to everyone. The tower that would embody this vision would rise on the north shore of Long Island, in a place called Shoreham. It would become known as Wardenclyffe Tower. It would be a structure of unprecedented scale and ambition, designed not to transmit radio signals, not to communicate messages, but to transmit power itself through the Earth and the atmosphere. Every detail of its construction would reflect Tesla's meticulous understanding of frequency, resonance, and the behavior of electromagnetic waves. Every aspect of its design would serve a single purpose: to prove that wireless power transmission was not merely possible, but practical, scalable, and ready to transform human civilization. This is the story of that tower. It is a story of scientific brilliance meeting financial intrigue. It is a story of hope meeting betrayal. It is a story that asks profound questions about who decides which technologies survive, which innovations flourish, and which dreams are permitted to reshape the world. As we explore this history, you may find yourself contemplating not just what happened more than a century ago, but what might be happening in your own time, in your own era, with technologies and possibilities that we cannot yet fully see. The journey begins with understanding the mind that conceived this vision. It continues with the construction of the tower itself. It moves through the scientific principles that made wireless power transmission theoretically possible. It confronts the financial decisions that would ultimately doom the project. And it concludes with a meditation on what Wardenclyffe still teaches us about innovation, resistance, and the eternal tension between human progress and the forces that seek to control it. Allow yourself to settle into this exploration. There is no rush. The story unfolds at its own pace, revealing layers of meaning with each step forward. The tower rises, Wardenclyffe's architecture and engineering ambition. The physical structure that Tesla envisioned was not arbitrary. Every dimension, every material, every engineering decision served the larger purpose of creating a device capable of transmitting electrical energy through the Earth and atmosphere. To understand Wardenclyffe Tower is to understand how Tesla translated his theoretical framework into concrete reality, how he transformed abstract principles of physics into steel and copper and earth. The tower itself was designed to be massive. Standing approximately 187 feet tall, it would dominate the landscape of Shoreham, New York, visible for miles across the flat terrain of Long Island. The structure was built upon a foundation that extended deep into the Earth, creating an enormous grounding system that connected the tower to the planet itself. This was intentional. Tesla believed that the Earth was not merely ground, but a conductor, a medium through which electrical energy could propagate just as it propagates through copper wire. The deeper the connection, the more direct the contact with this planetary conductor, the more effectively power could be transmitted. At the top of the tower sat a large hemispherical dome, a copper structure that would serve as the transmitter element. This dome was not decorative. It was engineered with precision to accumulate and radiate electrical energy at specific frequencies. The dome would be supplied with electricity, generated in a power plant located nearby. This electricity would be stepped up to extraordinarily high voltages through Tesla coils, creating the conditions necessary for wireless transmission. The entire structure functioned as a resonant circuit, carefully tuned so that the frequency of oscillation matched the natural resonant frequency of the Earth itself. Below the surface, an equally sophisticated system existed. Tesla designed the foundation to include a network of copper conductors that would spread through the Earth beneath the tower site. These conductors were not random. They followed patterns calculated to maximize the coupling between the electrical system and the planet. The idea was elegant in its conception. The tower above would transmit, the network below would couple the transmission to the Earth, and the Earth itself would become the transmission medium carrying electrical energy across continents. The building that housed the generating equipment was constructed with similar precision. The machinery inside was state-of-the-art for its time. Massive electrical generators would produce the current that would be fed into the Tesla coils at the base of the tower. These coils were wound with mathematical exactitude, their dimensions and spacing calculated to produce specific electromagnetic effects. The entire system was designed to operate at resonance, a state where the energy would build and amplify with each cycle, creating conditions where wireless transmission became theoretically possible. The engineering challenges were immense. Constructing such a tower with the materials and techniques available in the early 1900s required solving problems that had never been encountered before. The electrical stresses on the structure would be extraordinary. The equipment would generate voltages that could kill a man instantly. The mechanical stresses from wind and weather would test the structural integrity of materials in ways that previous engineers had never had to consider. Yet Tesla and his team moved forward with the construction, driven by confidence in the theoretical framework and by the urgent desire to prove the concept before skepticism could overwhelm the project. The location itself was chosen with deliberation. Shoreham, on the north shore of Long Island, offered several advantages. It was relatively isolated, which meant that the high-voltage experiments could be conducted without immediate danger to populated areas. It had access to water, which was essential for the steam-powered generators that would provide electricity. It was close enough to New York City that resources and expertise could be brought to the site, yet far enough away to provide the necessary separation from dense population centers. The geology of the area was also considered. Long Island's sandy and rocky composition offered certain electrical properties that Tesla believed would be favorable for his purposes. As construction proceeded, the tower began to transform from blueprint into three-dimensional reality. Workers erected the steel framework, riveting massive girders together to create a lattice structure that could support the enormous copper dome at its apex. The foundation work progressed simultaneously, with teams digging deep into the earth to establish the grounding system that would connect the tower to the planetary conductor below. The construction site became a hive of activity, with materials arriving regularly, with skilled workers laboring under Tesla's exacting specifications. The cost of the project escalated as construction continued. What had been estimated at $50,000 began to stretch toward $100,000, then beyond. Tesla's perfectionism meant that compromises were rarely accepted. If a material did not meet his specifications, it would be replaced. If a connection was not exactly as he had designed it, workers would redo the work until it matched his vision precisely. This commitment to excellence was admirable from a scientific standpoint, but it had financial consequences that would eventually contribute to the project's undoing. The tower that rose against the Long Island sky was unlike anything that had been constructed before. It was not a communication tower, though it resembled one. It was not a power transmission tower, though it would transmit power. It was something entirely new, a device that existed at the intersection of several scientific disciplines, embodying principles that most engineers of the time did not fully understand. To those who visited the site, the tower was impressive, even awe-inspiring. But to those who understood what Tesla intended it to do, it represented something far more significant. It was a physical manifestation of a radical idea about how human civilization could receive energy. The hemispherical dome at the top gleamed in the sunlight, a copper crown visible for miles across the flat landscape. The tower beneath it rose with geometric precision, its lattice structure creating patterns of light and shadow as the sun moved across the sky. Beneath the surface, the grounding conductors spread through the earth like the roots of an enormous tree, seeking connection with the planetary conductor that Tesla believed existed in the depths below. This was not merely a building project. This was an attempt to reshape the relationship between humanity and the forces of nature itself. Resonance and frequency. How Tesla imagined wireless power transmission. To understand how Tesla believed wireless power transmission could work, we must enter into the world of electromagnetic phenomena, of frequencies and resonances, of the invisible forces that move through space and through matter. This is not complicated technology described in jargon. This is the poetic reality of how energy behaves when certain conditions are met. Tesla's fundamental insight was this: the Earth itself is not merely solid ground, it is a conductor of electricity. Just as copper wire conducts electric current, the planet conducts electrical energy. Moreover, the Earth has natural frequencies at which it resonates, frequencies determined by its size, its composition, and its relationship to the electromagnetic forces that surround it. If one could generate electrical oscillations at exactly these resonant frequencies, Tesla reasoned, one could set up a standing wave pattern through the Earth, a pattern where energy would build and amplify, creating conditions for wireless power transmission across vast distances. Imagine a drum. When you strike it at precisely the right frequency, the entire surface vibrates in harmony. The vibration is not confined to the point where you struck. It spreads throughout the instrument, creating patterns of resonance. Now imagine the Earth as a vastly larger version of this drum. If electrical energy could be introduced at the right frequency, the entire planet could begin to resonate, and that resonance could be tapped into at other locations simply by having a receiving device tuned to the same frequency. This is the essence of Tesla's concept. He believed that by creating electrical oscillations at the Earth's natural resonant frequency, he could establish what he called standing waves in the Earth. These standing waves would be stationary patterns of electrical energy distributed throughout the planet. A transmitter at one location operating at this frequency would set up these waves. A receiver at any other location, also tuned to this frequency, could extract energy from these waves. The transmitter at Wardenclyffe would work as follows. Electrical power generated in the power plant would be fed into the Tesla coils at the base of the tower. These coils would step up the voltage to extraordinarily high levels, hundreds of thousands of volts. This high-voltage electricity would be discharged through the hemispherical dome at the top of the tower, creating electrical pulses. These pulses would oscillate at a carefully calculated frequency, the frequency at which Tesla believed the Earth naturally resonated. The electrical pulses would propagate in multiple directions simultaneously. Some would travel upward into the atmosphere. Some would travel downward through the deep grounding system into the Earth itself. The combination of these upward and downward propagating waves would create interference patterns, standing waves where the energy would concentrate and accumulate. These standing wave patterns would extend throughout the Earth and into the atmosphere, creating what Tesla called the terrestrial resonant cavity, a space defined by the Earth's surface below and the ionosphere above, where electromagnetic energy could propagate and resonate. A receiver located anywhere on the planet could be tuned to this same frequency. The receiver would consist of a similar tower, though much smaller and simpler than the Wardenclyffe transmitter. This receiver tower would have a coil connected to ground, similar to the transmitter. As the terrestrial resonant cavity oscillated at the resonant frequency, the receiver coil would experience a changing magnetic field. This changing field would induce an electrical current in the receiver coil, just as a changing magnetic field induces current in any conductor. This current could then be rectified and used to power electrical devices. The beauty of this concept, from Tesla's perspective, was that it required no continuous connection between transmitter and receiver. Once the standing waves were established in the terrestrial resonant cavity, any properly tuned receiver could extract energy from those waves. The energy would be transmitted not through wires or through direct line-of-sight radiation, but through the Earth itself, following the most efficient paths available to electromagnetic energy in the planetary environment. Tesla had conducted experiments that he believed supported this concept. He had measured what he called stationary waves in the Earth, and he interpreted these measurements as evidence that wireless power transmission was not merely theoretical but observable. He had transmitted signals wirelessly over distances of hundreds of miles using relatively low power, demonstrating that electromagnetic energy could propagate through the Earth and be detected at remote locations. To Tesla, these experiments were stepping stones toward the larger goal of wireless power transmission. The physics underlying this concept is more complex than Tesla's original formulation. Modern physics reveals both the brilliance of Tesla's intuition and the limitations of his understanding. Tesla was correct that the Earth can support electromagnetic resonances. The Schumann resonance, a frequency of approximately 7.83 Hz, is indeed a natural resonance of the Earth ionosphere system. However, the efficiency of power transmission through this mechanism is far lower than Tesla believed. Electromagnetic waves propagating through the Earth experience significant attenuation, a gradual weakening of the signal as energy is absorbed by the conductive properties of rock and soil. Nevertheless, Tesla's theoretical framework was not nonsensical. It was based on genuine electromagnetic principles. It was wrong about efficiency, wrong about the practical feasibility of transmitting useful amounts of power wirelessly over continental distances, but it was not incoherent or magical. It represented a genuine attempt to understand how electromagnetic energy behaves and to engineer a system that would exploit those behaviors. The Wardenclyffe Tower was designed as a practical test of these principles. If Tesla's calculations were correct, the tower would successfully transmit electrical energy through the Earth and atmosphere. Properly tuned receivers anywhere on the planet would be able to extract this energy and use it. If his calculations were wrong, the tower would fail to transmit significant power, and the entire project would be revealed as based on faulty assumptions. The tower itself, therefore, was not merely an impressive structure. It was an experiment, a test of a hypothesis about how the universe works. Every dimension of the tower, every engineering decision, every component was designed to maximize the likelihood that this experiment would succeed. The massive grounding system was designed to couple the electrical system to the Earth as efficiently as possible. The hemispherical dome was designed to radiate electromagnetic energy at the chosen frequency. The power plant was designed to generate the electrical pulses needed to excite the terrestrial resonant cavity. The entire system was integrated into a unified whole, each part serving the function of making wireless power transmission possible. The financier's gamble, JP. Morgan enters the story. The construction of Wardenclyffe Tower required capital. Vast sums of money were necessary to purchase materials, hire workers, design and construct the machinery, and conduct the experiments that would prove whether Tesla's theories were correct. Tesla himself did not possess such wealth. He was an inventor and a scientist, not a businessman or a financier. He required someone with access to extraordinary resources, someone who could fund the project and believe in its potential. That someone was John Pierpont Morgan, one of the most powerful financial figures in American history. Morgan controlled vast banking and industrial interests. He had financed railroads, supported industrial development, and accumulated wealth that gave him influence over the direction of American economic life. Morgan was not merely a banker, he was a power broker, a man whose decisions could shape entire industries and determine which technologies would flourish and which would fade into obscurity. How did Tesla come to approach Morgan? The path was not direct. Tesla had been working on wireless transmission concepts for years. He had demonstrated wireless communication over considerable distances. He had published papers and given lectures describing his theories about wireless power transmission. His reputation as an inventor was well established, though his financial situation was often precarious. Tesla moved between periods of success and periods of struggle, never quite achieving the stable wealth that would have allowed him to fund major projects independently. The opportunity to approach Morgan came through intermediaries, through connections in the scientific and business communities who believed in Tesla's vision and saw Morgan as the logical source of funding. Morgan himself was interested in new technologies. He had supported various innovations and had shown willingness to invest in ventures that promised significant returns or that advanced American technological leadership. Wireless transmission of any kind was a frontier technology, something that captured the imagination of forward-thinking investors. Tesla presented his vision to Morgan with characteristic precision and passion. The proposal was not merely for a tower, it was for a revolutionary system of wireless power transmission that would transform global civilization. Free energy, available everywhere on Earth, transmitted from a single point through the planet itself. The economic implications were staggering. The technological achievement would be unprecedented. The humanitarian benefits would be incalculable. For someone with Morgan's vision of progress and his hunger for influence over major technological developments, the proposal was compelling. Morgan agreed to fund the project. The agreement was made around 1901, and construction of Wardenclyffe Tower began. The initial funding was substantial, approximately $150,000, a sum equivalent to several $1 million in contemporary currency. This was serious money, representing Morgan's genuine commitment to seeing the project completed. But Morgan's agreement came with conditions. He was not funding this project out of pure altruism or scientific curiosity. Morgan was a businessman, and he expected returns on his investment. The conditions of the funding agreement reflected his interests and his need to protect his financial interests. Morgan required regular reports on the progress of the work. He maintained the right to inspect the facility and understand how his money was being spent. Most importantly, Morgan expected that once the technology was proven, he would have some degree of control over how it was commercialized and who would benefit from its development. The relationship between Tesla and Morgan was complex. They were aligned in their desire to see the tower completed and the technology demonstrated. But they operated from different motivations. Tesla was driven by the vision of free energy for humanity, by the dream of liberating people from dependence on centralized power systems. Morgan was interested in the technology as a source of power and influence, as a way to expand his industrial empire and his control over essential infrastructure. This fundamental difference in motivation would become increasingly significant as the project progressed. Tesla envisioned a system that would make energy abundant and free, available to everyone. Morgan envisioned a system that would give him unprecedented control over energy distribution, making him the central figure in a global wireless power transmission network. These two visions were incompatible. They could coexist as long as the tower remained theoretical, as long as wireless power transmission had not yet been proven. But once the technology worked, once it became clear that wireless transmission was actually possible, the question of control would become urgent. Morgan also had financial interests in existing power systems. He had investments in electric utilities, in coal mines that supplied electricity generation, in the infrastructure of centralized power distribution that dominated the American landscape. A successful wireless power transmission system would threaten these investments. If energy could be transmitted wirelessly, if it could be made abundant and free, then the entire existing system of power generation and distribution would become obsolete. The utilities in which Morgan had invested would lose their value. The coal mines would cease to be profitable. The entire infrastructure of centralized power would become a relic of the past. This created a profound tension. Morgan was funding a project that, if successful, would destroy the value of his own existing investments. This tension might have remained latent as long as the project seemed distant, as long as wireless power transmission remained theoretical. But as construction proceeded, as the tower took physical form, as the possibility of success became more real, this tension would begin to surface. The initial funding from Morgan allowed the project to move forward rapidly. Construction accelerated, equipment was ordered and installed, the power plant was built. The tower structure rose toward completion. Tesla and his team worked with intensity and dedication, driven by the belief that they were on the verge of a breakthrough that would reshape human civilization. Yet even during this period of progress, signs of tension began to appear. Tesla requested additional funding. The costs of the project had exceeded initial estimates. The machinery was more expensive than anticipated. The precision required for the construction was driving up labor costs. Tesla came back to Morgan, asking for more money to complete the work. Morgan was less enthusiastic about providing additional funds than he had been about the initial investment. He began to ask harder questions about the project's progress, about when wireless power transmission would actually be demonstrated, about what concrete evidence existed that the technology would work. Tesla's answers, while scientifically sound from his perspective, did not provide the kind of certainty that a banker required before committing additional capital. The relationship between the two men, never entirely comfortable, began to show signs of strain, construction and hope, building the dream at Shoreham. The construction of Wardenclyffe Tower proceeded through multiple stages, each bringing the project closer to completion and to the moment when Tesla's theories would be tested against physical reality. From 1901 through 1902, the work accelerated, driven by Tesla's urgency and by the initial confidence that had accompanied Morgan's funding. The first phase involved site preparation and the establishment of the deep grounding system. Teams of workers dug into the earth, creating the network of copper conductors that Tesla believed would couple the tower to the planetary conductor below. This work was physically demanding. The earth had to be excavated to considerable depths. Copper conductors had to be laid with precision, following the patterns that Tesla had designed. The work proceeded slowly, carefully, with Tesla himself often present to ensure that every detail matched his specifications. Simultaneously, the structural framework of the tower began to rise. Massive steel girders were delivered to the site and assembled into the lattice structure that would support the hemispherical copper dome at the top. The work of erecting the tower required skilled steelworkers, men experienced in working at heights, in bolting and riveting massive girders together. The tower grew week by week, its silhouette against the sky becoming increasingly prominent, increasingly impressive. The power plant facility was constructed nearby. This building would house the electrical generators and the Tesla coils that would produce the high-voltage electrical pulses needed for transmission. The machinery installed in this facility was state-of-the-art. The generators were capable of producing the electrical power needed to drive the system. The Tesla coils were wound with extraordinary precision, their dimensions calculated by Tesla to produce the specific electromagnetic effects he desired. The community of Shoreham watched the construction with a mixture of fascination and bewilderment. The tower was unlike anything that had been built before in their region. Workers came from outside the area, drawn by the wages available for skilled labor. The project brought economic activity to the area. Local suppliers provided materials. Local restaurants and boarding houses accommodated the workers who came to labor on the site. Tesla became a figure of some renown in the area. He was a foreigner, a man with an accent that marked him as different from the typical American businessman or engineer. He was exacting, demanding, precise in his requirements. Workers who failed to meet his standards found themselves corrected or reassigned. But there was also an undeniable quality of genius about him. Those who worked with him understood that they were participating in something extraordinary, something that might reshape how the world received energy. The work progressed through 1902 and into 1903. The tower structure was essentially complete by late 1902. The hemispherical dome had been installed at the top, a gleaming copper structure that caught the light and was visible for miles across the Long Island landscape. The power plant facility was operational. The grounding system was in place. The basic infrastructure for wireless power transmission was complete. Yet the project was not finished. Fine-tuning remained to be done. The electrical systems had to be tested. The coils had to be adjusted to produce precisely the frequencies that Tesla believed were necessary. Equipment had to be installed and calibrated. The work of transforming the physical structure into a functioning wireless power transmission system required additional time and additional resources. During this period, Tesla conducted various experiments with the tower. He transmitted signals wirelessly over distances of hundreds of miles, demonstrating that electromagnetic energy could propagate through the Earth and be detected at remote locations. He measured what he believed to be standing waves in the Earth, evidence that his theoretical framework was correct. He observed electrical phenomena that he interpreted as confirmation of his ideas about terrestrial resonance. These experiments were conducted with enthusiasm and with the conviction that they demonstrated the viability of wireless power transmission. Tesla reported his findings to Morgan, presenting them as evidence that the technology was working, that wireless power transmission was not merely theoretical but observable. The reports were encouraging, suggesting that the project was progressing toward its ultimate goal of demonstrating practical wireless power transmission on a large scale. However, not everyone interpreted these experiments as Tesla did. Some observers suggested that what Tesla was measuring was not proof of wireless power transmission, but rather evidence of other electromagnetic phenomena that did not necessarily support the larger claim that useful quantities of power could be transmitted wirelessly over continental distances. The distinction was subtle but important. Tesla saw his experiments as stepping stones toward the final goal. Others saw them as interesting, but not necessarily indicative of larger success. The tension between these interpretations began to affect the project's momentum. Morgan, reviewing the progress reports, began to wonder whether the tower would actually accomplish what Tesla had promised. The initial enthusiasm that had accompanied his funding decision was tempered by questions about whether wireless power transmission would actually work, about whether the investment would ultimately produce the revolutionary technology that had been promised. Tesla, for his part, remained convinced that he was on the verge of a breakthrough. He requested additional funding to complete the fine-tuning work and to conduct the final experiments that would demonstrate wireless power transmission conclusively. The request for more money, coming after the initial substantial investment, created friction with Morgan. The financier was beginning to question whether the project would ever reach completion, whether the technology would ever actually work. The community around Shoreham continued to observe the tower and the ongoing work. The structure had become a landmark, a visible symbol of Tesla's ambition and of the possibility of technological revolution. People speculated about what the tower would accomplish once it was fully operational. Some believed that it would transform the world. Others expressed skepticism, wondering whether such a radical technology could actually work, or whether it was merely the dream of an eccentric genius. The tower stood complete, but not yet proven. The machinery was installed, but not yet fully tested. The system was theoretically sound according to Tesla's calculations, but it had not yet demonstrated practical success. This was the state of the project as 1903 progressed, a state of anticipation mixed with growing uncertainty, of hope tempered by questions about whether the dream would actually become reality. The missing piece: why free energy? Threatened an empire to understand what happened to the Wardenclyffe Tower project, one must understand not merely the technical challenges or the financial constraints, but the fundamental economic threat that successful wireless power transmission would have posed. This is where the story moves beyond the realm of pure science and engineering into the realm of economics, politics, and power. This is where we encounter the forces that could suppress even the most brilliant technology if that technology threatened established systems of wealth and control. The existing system of power generation and distribution in the early 20th century was based on a simple economic model: centralized generation and metered distribution. Electricity was generated at large power plants, typically powered by coal. This electricity was transmitted through wires to cities and towns, where it was distributed to homes and businesses through a network of lines and transformers. The system required enormous infrastructure investment, creating barriers to entry that protected existing utilities from competition. The utilities then charged customers for the electricity they consumed, metering the usage and billing accordingly. This system was profitable for those who controlled the utilities and for the coal companies that supplied fuel for the generators. This economic model had been established and refined over decades. Powerful interests had invested billions of dollars in infrastructure, in power plants, in transmission lines, in the distribution networks that brought electricity to every major population center. These investments created enormous wealth for those who owned and controlled the utilities. More importantly, the system created dependencies. Consumers depended on the utilities for electricity. Businesses depended on the utilities for power. The entire modern economy was becoming dependent on centralized power distribution. Now, consider what would happen if wireless power transmission became practical and widespread. If energy could be transmitted wirelessly through the Earth and atmosphere, if it could be made abundant through a simple system of transmitters that required minimal infrastructure, then the entire existing system of centralized power generation and distribution would become obsolete. The power plants would cease to be necessary. The transmission lines would become useless. The distribution networks would be rendered irrelevant. The enormous infrastructure investments that had been made over decades would lose their value. Moreover, if wireless power transmission worked as Tesla envisioned, if it made energy abundant and available everywhere, then the business model of metering and selling electricity would no longer work. How do you charge customers for electricity if they can simply tap into the wireless transmission system available in their location? How do you maintain control over an essential resource if that resource becomes as abundant as air? The entire structure of wealth and power that had been built upon centralized power distribution would collapse. This was not a minor economic threat. This was a threat to fundamental systems of power and wealth. The utilities that controlled electricity distribution were among the largest and most profitable corporations in existence. The coal companies that supplied fuel for power generation were enormous enterprises with political influence. The financiers who had invested in these systems had vast fortunes dependent on their continued profitability. The engineers and business leaders who ran these systems had built their careers and their identities around maintaining and expanding centralized power systems. Against this massive array of established interests stood Tesla and his vision of wireless power transmission. Tesla had no army of shareholders demanding return on investment. He had no political allies powerful enough to reshape regulations in his favor. He had one major financial backer, J.P. Morgan, and even Morgan's commitment was beginning to waver as the project demanded more resources and failed to deliver the promised breakthrough. The threat posed by wireless power transmission was not merely economic, it was also political. Centralized power systems gave governments and powerful corporations the ability to control who received electricity and who did not. A government could cut off power to a city as a form of political control. A corporation could use the threat of cutting off power as leverage against workers or communities. Wireless power transmission would eliminate this form of control. If everyone could access power wirelessly, if the system could not be shut down from a central location, then this mechanism of political and economic control would disappear. Furthermore, wireless power transmission threatened the very structure of industrial capitalism as it had developed. The industrial economy depended on centralized control of resources and infrastructure. Factories, railroads, power plants, and distribution networks were all centralized, all controlled by corporations or governments, all sources of wealth and power for those who controlled them. A technology that made energy abundant and freely available would undermine this entire structure. It would shift power from centralized authorities to individuals and communities who could generate and access energy independently. This is why the question of suppression versus failure becomes so significant. When the Wardenclyffe Tower project was abandoned, when funding was withdrawn and the tower was left incomplete, was this simply because the technology did not work? Or was it because the technology threatened interests so powerful that they could not allow it to succeed, even if success was theoretically possible? The historical record does not provide a clear answer. There is no documented conspiracy, no smoking gun proving that powerful interests deliberately suppressed the technology. But neither is there evidence that the technology was abandoned solely because it was scientifically unsound. Tesla's theoretical framework, while not perfect, was based on genuine electromagnetic principles. His experiments, while not conclusive proof, did demonstrate wireless transmission of electromagnetic energy. The question of whether he could have achieved practical wireless power transmission on a large scale remains open. What is clear is that the economic interests threatened by wireless power transmission had every motivation to ensure that the technology did not succeed. Whether they acted consciously and deliberately to suppress it, or whether they simply made financial decisions that happened to doom the project, the result was the same. The technology did not survive. The tower was left incomplete. The experiments were not finished. The theory was not proven in practice. This raises a profound question about the relationship between economic systems and technological development. Do technologies succeed or fail based on their scientific merit and practical utility? Or do they succeed or fail based on whether they serve the interests of those with power and wealth? The history of technology is filled with examples that suggest the answer is more complicated than we might wish. Technologies that threaten established interests often struggle to survive, regardless of their potential benefits. Technologies that serve established interests flourish, even if they are less efficient or less beneficial than alternatives. Signals in the night. Experiments and early results. During the period when the Wardenclyffe Tower was being completed and fine-tuned, Tesla conducted a series of experiments designed to demonstrate the viability of wireless power transmission. These experiments were conducted both at the tower site and at remote locations, using various pieces of equipment and measuring devices to detect and quantify the wireless transmission of electromagnetic energy. One of the most significant experiments involved the transmission of electrical signals over a distance of approximately 200 miles. Tesla arranged for receiving equipment to be set up at a remote location, and he transmitted signals from the Wardenclyffe Tower. The signals were successfully detected at the receiving location, demonstrating that electromagnetic energy could propagate through the Earth and be received at a distance. This was not, strictly speaking, power transmission. The energy involved was relatively small, and the purpose was to demonstrate signal transmission rather than practical power delivery. But to Tesla, this experiment represented proof of concept, evidence that wireless transmission through the Earth was possible. Tesla also conducted experiments involving what he called standing waves in the Earth. Using sensitive measuring equipment, he detected electrical oscillations in the ground at various locations around the tower. He interpreted these measurements as evidence that standing wave patterns were being established in the Earth, patterns that confirmed his theoretical framework. The presence of these standing waves, he believed, demonstrated that the terrestrial resonant cavity was being excited by the tower's transmissions. That electromagnetic energy was indeed resonating through the planet as he had theorized. Additionally, Tesla reported observing unusual electrical phenomena in the vicinity of the tower. He described what he believed to be evidence of wireless transmission of electrical energy, of currents being induced in conductors that were not physically connected to any power source. These observations were exciting to Tesla and to those who worked with him. They suggested that the underlying principles of wireless power transmission were correct, that the tower was indeed establishing the conditions necessary for wireless transmission to occur. These experiments were conducted with enthusiasm and with careful documentation. Tesla kept detailed records of his observations, measurements, and interpretations. He reported his findings to Morgan and to other interested parties, presenting the results as evidence that the technology was working, that wireless power transmission was transitioning from theory to demonstrated reality. However, these experiments were also interpreted skeptically by some observers. Critics noted that while the experiments demonstrated wireless transmission of signals, they did not demonstrate wireless transmission of significant amounts of power. The energy involved in the signal transmissions was relatively small, and the efficiency of the transmission was not measured or quantified. The standing waves that Tesla reported detecting could have been the result of other electromagnetic phenomena. They were not necessarily proof of the specific type of terrestrial resonance that Tesla's theory required. Moreover, there was the question of whether the tower was actually transmitting energy wirelessly, or whether what Tesla was observing was simply normal electromagnetic radiation propagating through space and through the Earth. The distinction was important. Electromagnetic radiation propagates through space regardless of whether one is trying to establish standing waves or not. Detecting electromagnetic radiation at a distance from the tower did not necessarily prove that the tower was establishing the specific resonant conditions that Tesla believed were necessary for practical wireless power transmission. Despite these criticisms, the experiments represented genuine scientific work. Tesla was not conducting fraudulent experiments or making false claims. He was genuinely attempting to demonstrate wireless transmission, and he was interpreting his results through the lens of his theoretical framework. The problem was not dishonesty, but rather the ambiguity of the results. The experiments could be interpreted as supporting Tesla's theory, or they could be interpreted as demonstrating something less revolutionary than Tesla claimed. This ambiguity would become increasingly significant as questions about the project's viability mounted. The experiments also had a practical effect on Tesla's thinking and on his plans for the project. Each successful transmission, each observation of electrical phenomena that he interpreted as supporting his theory, reinforced his conviction that he was on the verge of a major breakthrough. He became increasingly confident that the tower would succeed, that wireless power transmission would soon be demonstrated conclusively. This confidence led him to make increasingly ambitious claims about what the tower would accomplish, and to request additional resources to complete the work and conduct the final experiments that would prove wireless power transmission beyond any doubt. The experiments were also observed and reported in the popular press. Newspapers carried stories about the mysterious tower on Long Island, about Tesla's experiments with wireless transmission, about the possibility of free energy available everywhere on Earth. These stories generated public interest and excitement. People speculated about what wireless power transmission would mean for society. Some saw it as a blessing that would liberate humanity from dependence on centralized power systems. Others viewed it with skepticism or even alarm, wondering whether such a radical technology could actually work or whether it posed unforeseen dangers. The experiments and the publicity surrounding them created a sense of momentum around the project. It seemed as though wireless power transmission was becoming real, that the tower would soon demonstrate the technology conclusively, that the world was on the verge of a revolutionary transformation in how energy was generated and distributed. This sense of momentum was important because it sustained the project through the difficult periods when funding was tight and when skepticism about the project's viability was growing. Yet beneath this surface momentum, there were troubling signs. The experiments, while encouraging to Tesla, had not produced the kind of decisive proof that would silence all skepticism. The tower, while nearly complete, remained untested for its ultimate purpose, the wireless transmission of significant amounts of electrical power. The funding from Morgan had been substantial, but it had not been unlimited, and additional requests for resources were being met with increasing resistance. The project was at a critical juncture, poised between potential success and possible failure, between the possibility of revolutionary breakthrough and the danger of abandonment. The silence begins, funding withdrawal and abandonment. The year 1904 marked a turning point in the history of Wardenclyffe Tower. This was the year when the momentum that had sustained the project began to falter, when hope began to give way to doubt, when the forces arrayed against wireless power transmission began to assert themselves more forcefully. The immediate cause of the crisis was financial. Tesla had again requested additional funding from Morgan to complete the final stages of the project and to conduct the definitive experiments that would prove wireless power transmission. The requests came at a time when Morgan himself was facing financial challenges. The American economy was experiencing turbulence, with stock market fluctuations and banking uncertainties creating an environment where financiers were becoming more cautious about their investments. But the financial difficulty was not the only factor. Morgan's enthusiasm for the project had waned considerably. He had been presented with reports and analyses from various engineers and scientists, some of whom expressed skepticism about whether the tower would actually accomplish what Tesla had promised. These skeptics pointed out that the experiments conducted so far had not definitively proven that wireless power transmission was practical. They noted that the efficiency of wireless transmission was likely to be poor, that significant energy would be lost in the transmission process, making the system impractical for large-scale power distribution. Moreover, Morgan's existing business interests in centralized power systems and coal mining had become more important to his thinking. He had invested heavily in these industries, and he was beginning to recognize that a successful wireless power transmission system would threaten these investments. The initial excitement about the revolutionary potential of the technology was giving way to concern about how wireless transmission would affect his existing financial interests. In 1904, Morgan made his decision. He would not provide additional funding for the Wardenclyffe Tower project. The decision was communicated to Tesla with finality. There would be no more money. The project, while not officially cancelled, would effectively be abandoned. The tower would stand incomplete, the experiments would remain unfinished, and the question of whether wireless power transmission could actually work would remain unanswered. The impact on Tesla was devastating. He had devoted years of his life to the project. He had invested his reputation in the promise that wireless power transmission would revolutionize human civilization. He had believed with absolute conviction that the tower would succeed, that his theories would be proven correct, that the world would be transformed by this technology. Now, with funding withdrawn, that dream was effectively dead. The workers at the Shoreham site were laid off. The construction equipment was removed or abandoned. The ongoing experiments ceased. The power plant facility, which had been prepared to generate the electrical pulses needed for the tower to function, fell silent. The tower itself stood complete but inert, a copper-crowned monument to ambition and to the collision between revolutionary vision and economic reality. Tesla faced financial ruin. The project had consumed vast amounts of resources, and without the promised returns from successful commercialization of wireless power transmission, those resources represented losses rather than investments. Tesla's financial situation, always precarious, became desperate. He owed money to suppliers and workers. He struggled to find funding for other projects. The years following the abandonment of Wardenclyffe were years of increasing financial difficulty and personal hardship for Tesla. The public perception of the project shifted. Where there had been excitement and anticipation about the tower and what it would accomplish, there was now skepticism and disappointment. The popular press, which had carried enthusiastic stories about wireless power transmission and the revolutionary tower on Long Island, now began to treat the project as a failure, as an example of visionary thinking that had not translated into practical reality. Tesla's reputation, while not destroyed, was damaged by the project's abandonment. The tower itself became a symbol of unfulfilled promise. It stood on the Shoreham site, incomplete and unused, gradually falling into disrepair. The hemispherical dome at its top remained visible for miles across the Long Island landscape, but it no longer transmitted the powerful electrical pulses that Tesla had envisioned. The copper conductors buried in the earth beneath the tower remained inert, never fulfilling their intended purpose of coupling electrical energy to the planetary conductor below. In the years following the project's abandonment, various attempts were made to revive it or to complete it. Tesla himself never entirely gave up hope that wireless power transmission would eventually be proven and commercialized. He continued to write about the technology, to refine his theories, to argue that the tower could have worked if given sufficient resources and time. Other scientists and engineers became interested in the technology, and some attempted to continue Tesla's work or to develop wireless power transmission through alternative approaches. But the momentum was lost. The critical moment had passed. The tower would never be completed as Tesla had intended. The experiments would never be finished. The question of whether wireless power transmission was practical would remain unanswered, at least through Tesla's original approach. The silence that began in 1904, when Morgan withdrew his funding, would extend through the remainder of Tesla's life and beyond. The tower would stand as a monument to what might have been a physical embodiment of the gap between visionary imagination and economic reality. Suppression or misunderstanding, examining historical claims. The abandonment of the Wardenclyffe Tower project has given rise to numerous historical narratives, some suggesting that the project was deliberately suppressed by powerful interests, threatened by the technology, others arguing that the project failed simply because the technology did not work. The truth is more complex than either narrative alone can capture, and it requires careful examination of what actually happened and what the evidence actually shows. The suppression narrative is compelling. It offers a clear story. Tesla discovered wireless power transmission, which threatened the interests of those who profited from centralized power systems, and these interests deliberately suppressed the technology to protect their profits. In this narrative, Morgan's withdrawal of funding is not a simple business decision, but an act of deliberate sabotage, a choice made to ensure that a technology that would have disrupted his business interests would never be completed. There is some basis for this narrative in historical fact. Morgan did have significant financial interests in centralized power systems and coal mining. He would indeed have benefited from the failure of wireless power transmission technology. He was a man capable of making ruthless business decisions to protect his interests. The economic threat posed by successful wireless power transmission was real and substantial. It is entirely plausible that Morgan, recognizing this threat, decided to withdraw funding to prevent the technology from being developed. However, the historical record does not provide definitive evidence of deliberate suppression. Morgan's withdrawal of funding was justified, at least officially, by concerns about the project's viability and by the lack of decisive proof that wireless power transmission would actually work. These concerns were not entirely unreasonable. The tower had not yet demonstrated practical wireless power transmission. The experiments, while encouraging to Tesla, had not provided conclusive proof that the technology was feasible. From a banker's perspective, the project represented an increasingly risky investment with uncertain returns. Moreover, other factors contributed to the project's abandonment beyond Morgan's financial interests. The American economy was experiencing financial turbulence in 1904. Morgan himself was facing financial pressures and was becoming more cautious about his investments. The skepticism expressed by various engineers and scientists about the project's viability was genuine. These people were not simply tools of suppression, but were expressing legitimate scientific concerns about whether Tesla's approach would actually work. The alternative narrative suggests that the project failed simply because Tesla's theory was wrong, because wireless power transmission through the Earth at practical scales was not actually possible. According to this narrative, the tower was abandoned not because of suppression, but because the technology did not work and would not have worked regardless of how much additional funding had been provided. From this perspective, the tower stands as a monument to brilliant but ultimately misguided scientific thinking, an example of how even a genius like Tesla could pursue an idea that, while theoretically interesting, was not practically feasible. There is also evidence supporting this narrative. Tesla's theories about wireless power transmission, while based on genuine electromagnetic principles, overestimated the efficiency of transmission through the Earth. Modern physics suggests that the attenuation of electromagnetic waves propagating through conductive Earth would be far greater than Tesla believed, meaning that the efficiency of power transmission would be too low to be practical. The standing waves that Tesla reported detecting could have been caused by conventional electromagnetic radiation rather than by the specific type of terrestrial resonance that his theory required. The experiments he conducted while demonstrating wireless transmission of signals did not demonstrate wireless transmission of significant amounts of power at useful efficiency. The truth appears to lie somewhere between these two narratives. Tesla's theory was not entirely wrong. It was based on genuine electromagnetic principles and on observations that suggested wireless transmission of electromagnetic energy was possible. However, the theory overestimated the practical feasibility of wireless power transmission, particularly at the scale and efficiency that would have been necessary to make the technology economically viable as a replacement for centralized power systems. Simultaneously, the economic interests threatened by wireless power transmission did exist, and they did create pressure against the project's continuation. Morgan's withdrawal of funding was likely influenced by his recognition of the economic threat that successful wireless power transmission would pose to his existing investments. The skepticism about the project that came from various sources was not entirely independent. It was influenced by the interests of those who would have benefited from the project's failure. What appears to have happened is a convergence of factors. Tesla's theory was not as sound as he believed. The technology was not as close to practical success as he claimed. The economic obstacles to the technology's development were real and substantial. And the financial pressures on Morgan created an opportunity for him to withdraw funding while maintaining the appearance of a rational business decision. The project failed not because of a single cause, but because of the combination of scientific limitations, economic barriers, and financial pressures. This more nuanced understanding does not diminish the significance of the suppression question. Even if Tesla's technology was not as practical as he believed, the question of whether more powerful interests deliberately suppressed development of a technology that threatened their profits remains important. Whether wireless power transmission would have actually worked as Tesla envisioned, the fact remains that the project was abandoned at least partly because it threatened established economic interests. The tension between scientific innovation and economic protection of existing systems remains real and relevant. The physics beneath the myth. Modern science evaluates Tesla's theory. To understand what Wardenclyffe Tower represents in the context of contemporary physics, we must examine Tesla's theories about wireless power transmission through the lens of modern electromagnetic science. This requires looking at both where Tesla's thinking was prescient and where it was limited by the understanding available in his time. Tesla was correct that the Earth can support electromagnetic oscillations and resonances. The Schumann resonance, a frequency of approximately 7.83 Hz, is indeed a natural resonance of the Earth ionosphere system. This resonance arises because the Earth and the ionosphere form a spherical cavity, and electromagnetic waves can propagate around the planet while bouncing between the Earth's surface and the ionosphere. At certain frequencies, these propagating waves constructively interfere, creating standing wave patterns. Tesla's fundamental insight that the Earth could be used as a medium for electromagnetic propagation was not wrong. However, modern physics reveals significant limitations in Tesla's approach. The Schumann resonance operates at very low frequencies, frequencies far below the frequencies that Tesla was working with at Wardenclyffe. The efficiency of electromagnetic energy transmission at these low frequencies is extraordinarily poor. Massive antennas would be required to couple electromagnetic energy into the Schumann resonance effectively, and the power that could be transmitted would be extremely small relative to the power input required to generate it. Moreover, Tesla's theory underestimated the attenuation of electromagnetic waves propagating through the conductive Earth. Electromagnetic waves lose energy as they propagate through conductive materials. The Earth, particularly in regions with significant mineral content and groundwater, is a reasonably good conductor of electricity. This conductivity means that electromagnetic waves propagating through the Earth are rapidly attenuated, losing energy as they travel. The attenuation increases with frequency, meaning that the higher frequency waves that Tesla was working with would be attenuated far more rapidly than lower frequency waves. The efficiency of wireless power transmission through the Earth can be estimated using the electromagnetic theory that was partially understood in Tesla's time, but was fully developed only in the decades following his work. These calculations show that the efficiency of power transmission through the Earth decreases rapidly with distance and with the frequencies involved. For practical power transmission across continental distances, the efficiency would be so low that the system would be fundamentally uneconomical. The power required to transmit a useful amount of electricity wirelessly would far exceed the power that could be received at a distance. Additionally, modern physics reveals that there are more efficient mechanisms for wireless power transmission than the terrestrial propagation that Tesla envisioned. Electromagnetic radiation propagating through free space, while also subject to losses that increase with distance, follows a different loss law than propagation through conductive Earth. At certain frequencies and distances, electromagnetic radiation through space can be more efficient than propagation through the Earth. This is the principle behind modern wireless power transmission technologies, which use electromagnetic radiation rather than terrestrial propagation as the transmission medium. Tesla's theory of wireless power transmission through standing waves in the Earth ionosphere cavity is therefore limited by the physics of electromagnetic propagation. While the theory is not nonsensical or magical, it overestimates the practical feasibility of the technology. The efficiency of power transmission through the Earth at the frequencies and scales that Tesla was working with would have been too low to make the system economically viable. However, this does not mean that wireless power transmission is impossible. Modern technologies demonstrate that electromagnetic energy can indeed be transmitted wirelessly and received at useful efficiency over practical distances. These technologies use different mechanisms than Tesla envisioned, but they build on principles that Tesla understood. Wireless charging of mobile devices, for example, uses electromagnetic induction at short range, transmitting power through magnetic fields over distances of a few centimeters to a few meters. Microwave power transmission uses electromagnetic radiation in the microwave frequency range, which propagates through the atmosphere more efficiently than the frequencies Tesla was working with. Contemporary research into wireless power transmission continues to explore new approaches. Some researchers are investigating resonant inductive coupling, a mechanism where two tuned circuits exchange energy through their mutual electromagnetic fields. This mechanism can achieve higher efficiency over greater distances than simple electromagnetic induction, though it still operates over relatively short ranges compared to what Tesla envisioned. Other researchers are exploring the possibility of transmitting power through the ionosphere using electromagnetic waves, building on Tesla's fundamental insight that the Earth ionosphere system can propagate electromagnetic energy. From the perspective of modern physics, Tesla's vision of free energy transmitted wirelessly to every location on Earth remains unrealized. The efficiency limitations of wireless power transmission mean that the technology will always involve losses, meaning that the power transmitted must exceed the power received. This is a fundamental constraint imposed by the laws of physics, not merely a limitation of current technology. It means that wireless power transmission will never provide truly free energy. There will always be a cost associated with the transmission losses. Nevertheless, Tesla's core insight was not wrong. Electromagnetic energy can be transmitted through the Earth and through the atmosphere. Wireless transmission of power is possible, even if it is not as efficient or as revolutionary as Tesla imagined. The Wardenclyffe Tower, had it been completed and had the experiments been finished, would likely have demonstrated wireless transmission of electromagnetic energy, though probably not at the scale or efficiency that Tesla hoped for. Fagos in technology. How Tesla's ideas resurfaced today. The Wardenclyffe Tower may stand abandoned on Long Island, but Tesla's ideas about wireless power transmission did not die with the project's abandonment. Instead, they have echoed through the decades, influencing researchers and engineers who have continued to explore the possibilities of wireless transmission of electromagnetic energy. Modern technologies demonstrate that wireless power transmission is indeed possible, even if the revolutionary vision of free energy everywhere remains unfulfilled. Wireless charging of mobile devices represents one direct application of principles that trace back to Tesla's work. When you place a smartphone on a wireless charging pad, power is transmitted from the pad to the device through electromagnetic induction. The charging pad contains a coil of wire, and when electrical current flows through this coil, it creates a magnetic field. The smartphone contains a receiver coil, and as the magnetic field from the charging pad passes through this receiver coil, it induces an electrical current in the receiver coil. This induced current is then rectified and used to charge the phone's battery. This mechanism operates over distances of a few millimeters to a few centimeters. It is far more limited in range than Tesla's vision of worldwide wireless power transmission, but it demonstrates the fundamental principle that electromagnetic energy can be transmitted from a transmitter to a receiver without physical connection. The efficiency of modern wireless charging is reasonably good, typically 50 to 80%, meaning that most of the power input to the transmitter is successfully transferred to the receiver. More advanced wireless power transmission technologies are being developed that extend the range and improve the efficiency of power transfer. Resonant inductive coupling, a technique where two tuned circuits are designed to resonate at the same frequency, can transmit power over distances of up to several meters with reasonable efficiency. This technology has been demonstrated in laboratory settings and is beginning to appear in commercial applications, such as wireless charging systems for electric vehicles that can transfer power from a charging pad in the ground to a receiver coil on the vehicle. Microwave power transmission represents another approach that traces back to principles that Tesla understood. In microwave power transmission, electromagnetic energy in the microwave frequency range is generated, focused into a beam, and transmitted through the atmosphere to a receiver that converts the electromagnetic radiation back into electrical power. This technology was developed primarily for the purpose of transmitting solar power from space-based solar arrays to ground receivers, but the same principles could be applied to terrestrial wireless power transmission. Microwave power transmission can operate over distances of hundreds of meters to kilometers, though the efficiency decreases with distance due to atmospheric absorption and beam spreading. Research into wireless power transmission continues at universities and in private companies around the world. Scientists are exploring new frequency ranges, new modulation schemes, and new receiver designs that could improve the efficiency of wireless power transmission or extend its range. Some researchers are investigating the use of terahertz radiation, electromagnetic radiation at frequencies higher than microwaves but lower than visible light, for wireless power transmission. Others are exploring the possibility of using metamaterials, engineered materials with properties not found in nature, to improve the efficiency of wireless power transmission at specific frequencies and distances. Perhaps most intriguingly, some contemporary researchers have revisited Tesla's original concept of using the Earth and ionosphere as a transmission medium. These researchers have conducted experiments similar to those that Tesla conducted more than a century ago, measuring electromagnetic oscillations in the ground and in the atmosphere, investigating whether wireless transmission through the Earth is possible. While these experiments have not led to the development of practical wireless power transmission systems using terrestrial propagation, they have confirmed that Tesla's fundamental insight was not wrong. Electromagnetic energy can indeed propagate through the Earth and be detected at remote locations. The applications of wireless power transmission that have been successfully developed demonstrate that Tesla's vision was not entirely mistaken, even though the specific mechanism he envisioned may not be the most practical approach. Wireless power transmission is real. It works. It is becoming increasingly common in everyday technology. The revolution in how power is transmitted and distributed has not yet happened at the scale that Tesla imagined, but the technological foundation for such a revolution has been laid. What remains unfulfilled is the vision of wireless power transmission as a replacement for centralized power systems, as a mechanism for making energy abundant and available everywhere on Earth. This vision remains unrealized not because wireless power transmission is impossible, but because the efficiency limitations and the economic factors that oppose the Wardenclyffe Tower project continue to operate. Wireless power transmission remains more expensive and less efficient than centralized power systems for large-scale energy distribution. As long as this remains true, centralized power systems will continue to dominate, even though wireless alternatives exist. The human cost, what Wardenclyffe meant for Tesla. To speak of Wardenclyffe Tower and its abandonment is not merely to discuss a failed technological project or a collision between scientific vision and economic reality. It is also to speak of the human cost, of what the project meant to the man who conceived it, who devoted his life to its realization, and who witnessed its abandonment and failure. Nikola Tesla was a man of extraordinary intellectual power and extraordinary personal difficulty. His genius was undeniable, his contributions to technology and science revolutionary, yet he was also a man who struggled with isolation, with financial insecurity, with the gap between his visions and the world's willingness to fund their realization. Tesla had lived a life of extremes, periods of great success and recognition, alternating with periods of obscurity and financial hardship. The Wardenclyffe Tower project represented Tesla's greatest hope. It was not merely another invention or another application of electromagnetic principles. It was the embodiment of his deepest conviction about the potential for technology to transform human civilization. In wireless power transmission, Tesla saw the possibility of liberating humanity from dependence on centralized power systems, of making energy abundant and free, of using his genius to benefit all of humanity rather than to enrich corporations and powerful individuals. For years, Tesla worked on the project with single-minded dedication. He designed every aspect of the tower with meticulous precision. He supervised the construction personally, ensuring that every detail matched his vision. He conducted experiments and interpreted their results as evidence that his theories were correct, that wireless power transmission was not merely theoretical, but was becoming real. He believed that he was on the verge of a breakthrough that would change the world. When Morgan withdrew funding, when the project was abandoned, when it became clear that wireless power transmission would not be demonstrated through the Wardenclyffe Tower, the impact on Tesla was profound. This was not merely a business failure or a setback in his career. This was the destruction of his life's great vision, the end of his hope that he would accomplish the work that he believed was his ultimate purpose. In the years following the project's abandonment, Tesla's financial situation deteriorated significantly. He owed money to suppliers and workers. He struggled to find new sources of funding for other projects. The resources he had devoted to the Wardenclyffe project, resources that he had believed would be repaid through the commercialization of wireless power transmission, instead represented devastating losses. Tesla's financial desperation increased, and he spent his later years struggling with poverty, with illness, with the knowledge that his greatest vision had not been realized. Tesla's reputation also suffered. Where he had previously been celebrated as a genius inventor and scientist, he increasingly became known as an eccentric visionary whose grand projects often failed to achieve their promised results. The popular perception of Tesla shifted from admiration to skepticism. People who had been excited about wireless power transmission and the Wardenclyffe Tower began to question whether Tesla's vision had ever been realistic, whether his theories had ever been sound. Tesla himself never entirely accepted that the project had failed. He continued to believe that wireless power transmission was possible, that it would eventually be demonstrated, that history would vindicate his vision. He wrote extensively about the technology, refining his theories and responding to criticisms. He sought funding from various sources to continue his work or to build new versions of his wireless power transmission system. But the resources never materialized. The opportunity that had existed when Morgan was willing to fund the project never returned. In his later years, Tesla lived in increasing isolation and poverty. He spent much of his time in his laboratory, continuing to conduct experiments, continuing to refine his theories, continuing to believe that wireless power transmission would eventually be proven and would transform civilization. But he knew at some level that the great opportunity had passed, that the Wardenclyffe Tower would never be completed as he had envisioned, that his greatest vision would not be realized during his lifetime. Tesla died in 1943, largely forgotten by the public, his financial situation desperate, his great projects unrealized. The Wardenclyffe Tower stood on Long Island, a monument to his ambition and to his failure. It was eventually demolished in the 1970s, but not before becoming a symbol in popular culture of the visionary genius whose ideas were too far ahead of their time, or perhaps too threatening to established interests to be realized. The human cost of Wardenclyffe was measured in the decades of disappointment, in the financial ruin, in the isolation and obscurity that followed what had seemed like the greatest opportunity of Tesla's life. It was measured in the gap between the vision of what could have been and the reality of what actually happened. It was measured in the pain of watching a lifetime's work come to nothing, or at least to nothing visible or tangible. Between dreams and reality, the eternal tension. The story of Wardenclyffe Tower raises fundamental questions about the relationship between scientific innovation and the forces that determine which innovations succeed and which fail. These questions extend far beyond the specific case of Tesla and wireless power transmission. They address issues that remain relevant to our own time. Issues about how we decide which technologies to develop, which to abandon, and which to suppress. Throughout human history, revolutionary technologies have faced resistance from those whose interests were threatened by their development. The printing press faced opposition from those who controlled the distribution of written material. The steam engine faced opposition from those whose wealth depended on traditional forms of labor. Electrical power faced opposition from those who profited from gas lighting and other existing energy sources. The pattern repeats itself across history. New technologies that promise to disrupt established systems face resistance from those who benefit from those systems. Yet not all resistance to new technologies is suppression or conspiracy. Some technologies genuinely do not work, or do not work as effectively as their proponents claim. Some technologies have unintended consequences or create new problems that outweigh their benefits. Some resistance to new technologies represents legitimate skepticism, careful evaluation of whether the technology actually delivers what is promised, whether it is worth the investment required to develop it. The question becomes, how do we distinguish between legitimate skepticism about a technology's viability and resistance motivated by economic self-interest? How do we determine whether a technology was abandoned because it did not work or because powerful interests suppressed it? These questions rarely have clear answers. Usually, both factors are present to some degree. A technology might have genuine limitations that make it impractical, while simultaneously being opposed by interests that would be threatened if the technology were overcome. The Wardenclyffe Tower project appears to have been a case where both factors were present. Tesla's theory of wireless power transmission was based on genuine electromagnetic principles, but it overestimated the practical feasibility of the technology. The efficiency of wireless power transmission through the Earth would have been too low to make the system economically viable as a replacement for centralized power systems. At the same time, Morgan and others with financial interests in centralized power systems had every reason to oppose the project's success, and Morgan's withdrawal of funding was likely influenced by his recognition of the economic threat that wireless power transmission would pose. This convergence of factors is important. It suggests that the outcome of technological development is not determined solely by scientific merit or practical utility, nor is it determined solely by the economic interests of powerful actors. Instead, technological development is shaped by a complex interaction of factors: the actual scientific feasibility of the technology, the perceived feasibility as understood by potential funders and investors, the economic interests of those with power and resources, the availability of funding and resources, the political and regulatory environment, and various other factors. Understanding this complexity does not mean abandoning the hope that good technologies will succeed and bad technologies will fail. It means recognizing that technological success and failure are not determined by technical merit alone. It means being more thoughtful and more critical about why certain technologies succeed while others fail. It means asking hard questions about whose interests are served by the technologies that we develop and deploy, and whose interests are harmed. The tension between dreams and reality, between visionary thinking and practical constraints, between the desire to revolutionize civilization and the forces that resist such revolution, is not unique to Tesla and wireless power transmission. It is a fundamental feature of technological development, a feature that will continue to shape which innovations are pursued and which are abandoned. Understanding this tension is important for anyone who cares about technological progress, about innovation, about the direction that human civilization takes. The Wardenclyffe Tower stands as a physical manifestation of this tension. It is a monument to the power of visionary thinking, to the possibility of revolutionary change, to the human capacity to imagine and attempt to build radically new technologies. But it is also a monument to the limitations of visionary thinking, to the gap between imagination and practical reality, to the forces that can prevent even brilliant ideas from being realized. The tower's shadow, what Wardenclyffe still teaches us. More than a century has passed since the Wardenclyffe Tower project was abandoned, yet the tower still casts a shadow across our understanding of technology, innovation, and the forces that shape technological development. The tower is no longer physically present. It was demolished in the 1970s, but the questions it raises remain, and the lessons it offers remain relevant to our own era. The first lesson that Wardenclyffe teaches us is that visionary thinking matters. Tesla's vision of wireless power transmission was not merely fantasy. It was based on genuine scientific principles, on careful calculation, on mathematical reasoning. While the vision was not entirely practical as conceived, it pointed toward real possibilities that have been partially realized in contemporary technology. The existence of wireless charging, of resonant inductive coupling, of microwave power transmission, all traces back to Tesla's fundamental insight that electromagnetic energy can be transmitted wirelessly. Visionary thinking, even when it overestimates what is currently possible, can point toward genuine innovations that will eventually be realized. The second lesson is that economic interests shape technological development in ways that are not always obvious or transparent. The abandonment of Wardenclyffe Tower was not simply because the technology did not work. It was because the technology, if it had worked, would have threatened the economic interests of powerful people. Morgan's withdrawal of funding, while presented as a rational business decision, was influenced by his recognition that wireless power transmission would disrupt his existing business interests. This pattern repeats itself throughout the history of technology. Technologies that threaten established economic interests face resistance, even when those technologies would benefit humanity more broadly. Understanding this dynamic is important for anyone who wants to think critically about which technologies are developed and which are not. The third lesson is about the importance of skepticism, both toward claims made by proponents of new technologies and toward the claims made by defenders of existing systems. Tesla made claims about wireless power transmission that were more optimistic than the actual physics would support. He overestimated the efficiency of the technology and underestimated the obstacles to its practical implementation. At the same time, those who opposed the project may have been motivated by economic self-interest rather than by genuine scientific skepticism. Neither side had a monopoly on truth. Neither side was entirely wrong or entirely right. This suggests that we should approach claims about new technologies with careful evaluation, considering both the scientific evidence and the economic interests of those making the claims. The fourth lesson concerns the relationship between technological possibility and economic viability. Something can be technologically possible without being economically viable. Wireless power transmission may be technologically feasible, but if it is significantly more expensive and less efficient than alternatives, it will not be adopted on a large scale. This is not a failure of the technology, it is a reflection of the economic realities that shape which technologies are actually deployed. Understanding this distinction is important for evaluating new technologies and for predicting which ones will actually transform society and which will remain niche applications. The fifth lesson is about the importance of funding and resources in determining which technologies succeed. The Wardenclyffe Tower project had significant funding for its time, but it was not enough to complete the project and prove the technology conclusively. Many potentially valuable technologies never get developed because funding is not available. The question of who controls funding, who decides which technologies are worth investing in, is therefore a crucial question in determining the direction of technological development. Here, funding is controlled primarily by those with interests in maintaining existing systems, then technologies that would disrupt those systems are less likely to receive funding. Looking at our own era, we can see these lessons playing out repeatedly. Renewable energy technologies face resistance from those with interests in fossil fuel industries, yet they continue to develop because some funding sources see them as economically viable or see supporting them as aligned with their values. Electric vehicles face resistance from those profited by petroleum industries, yet they continue to develop because the technology is becoming economically competitive. Technologies that could reduce corporate profits or disrupt established business models face obstacles, yet some succeed anyway through persistence, through alternative funding sources, through the gradual shift in economic conditions that makes the new technology more competitive than the old. The question that Wardenclyffe still raises for us is this: what technologies are we not developing right now because of economic interests that oppose them? What innovations are being suppressed, not through conscious conspiracy, but through the simple fact that funding is not available for them because they would disrupt established interests? What visionary ideas are being dismissed as impractical when they might actually be the seeds of revolutionary change? These are not questions with easy answers, but they are questions worth asking, questions that become more important as technology increasingly shapes human civilization. The Wardenclyffe Tower teaches us that technological development is not a simple process where good ideas succeed and bad ideas fail. It is a complex process shaped by scientific possibility, by economic interests, by the availability of resources and funding, by the political environment, and by the vision and persistence of those who believe in new possibilities. Understanding this complexity does not mean abandoning hope in technological progress. Rather, it means being more thoughtful, more critical, and more aware of the forces that shape which innovations are pursued and which are left behind. As you contemplate what you have learned in this exploration of wireless power transmission, of Tesla's vision, of the Wardenclyffe Tower and its abandonment, consider what might be developing in your own era that faces similar obstacles. Consider what technologies might be suppressed not through conscious conspiracy, but through the simple economic fact that they would disrupt established interests. Consider what visionary thinking might be dismissed as impractical when it could point toward genuine innovations. Consider what role you might play in supporting technologies that you believe in, even when powerful interests oppose them. Thank you for joining me on this journey through history, science, and the forces that shape technological development. If this exploration has brought you reflection and contemplation, I would appreciate a like and a subscription to Relaxing Science. Share with us in the comments. What technologies do you think are being suppressed or overlooked because of economic interests? What visionary ideas do you believe in, even if they seem impractical today? Your thoughts matter, and your engagement helps us continue exploring these mysteries that reshape how we understand our world and our future. Until next time, may you find peace in contemplation, and may you continue to question, to wonder, and to imagine the possibilities that lie beyond what currently exists. Total.